We're in our unit on quadratic functions in various forms. We've looked a lot at intercept form. We looked a lot at vertex form. Here's the third and final form of a quadratic. We're going to be asked to graph and identify different properties of a parabola on. Standard form is y equals ax squared plus bx plus c. It's in standard form because the powers go down in descending order from one term to the next, just like we talked about in our last unit. The second power comes first. That's the first power, and then a constant at the end. Standard form is what you multiply and get out after you multiply all the factors. All those similar properties we've talked about for vertex form and intercept form are now for standard form. Just like the first two, the leading coefficient, your a value, determines how the graph opens, either concave up or concave down. When a is greater than 0 or positive, it's opening up. When a is less than 0 or negative, your graph is concave down. X and Y intercepts. How do you figure out where the graph crosses through either axis? For the x-intercept, what must y always be equal to, just in general? No matter what, we should at least know this.
0.
0. On the x-axis, moving left and right, y is always 0. So start there. Replace y with 0. Plug in 0 for y, and take that resulting equation, and you can solve it by factoring. X-intercept, plug in 0 for y. That final equation you should solve by factoring. The y-intercept, any point on the y-axis. Similarly, what must x be equal to? Any point on the y-axis, x has to become what? 0. Plug in 0 for x. Let me make up an equation here. Y equals 3x squared minus 5x plus 2. Let's plug in 0 for x. Let's find the y-intercept. I'm going to change each of these x's to zeros. Instead of 3x squared, how about 3 times 0 squared? 5x is 5 times 0. I'll just bring down the plus 2. Luke, what's 0 squared?
0.
So 3 times 0 would just be 0. Do the power first. 0 squared's got to come before you multiply by 3. I was asked that last hour. Power's got to come first. 0 squared is 0. 3 times 0 is 0. How about the next term? Minus 5 times 0. What's 5 times 0? 0. So I'll bring down minus 0 plus 2. What's all I have left over now? 2. Your y-intercept is 0, 2. Your y-intercept is what you have left over when you plug in 0 for x. Wouldn't these first two terms always have to be 0 when you plug in 0 for x? Because anything times 0 plus anything times 0 is always going to be 0. All you have left over is the constant, because that's the only thing that doesn't have x in it. That's the only thing that didn't go to 0 when you plugged in 0 for x. Your y-intercept is always going to be 0, comma, c. I think standard form is probably the easiest to find the y-intercept with, because it's always just this last number. It's always the constant, because that's what's left over after everything else went to 0. Every other term became 0. Y-intercept is the constant, 0, comma, c. Finding the vertex. It's going to be a little bit different. We need this formula. To find the vertex, I need the xy ordered pair. The x-coordinate is found by using this formula. Negative b divided by 2a. Opposite of b over 2a gets you the x-coordinate of the vertex when your expression's in standard form. To find x, use negative b over 2a. That's half the story, because for every x value, what's the y value? Just plug in that x-coordinate to your expression to find the corresponding y value. Find x by getting negative b over 2a calculated, and then just plug that x value in to find the y-coordinate for your vertex. Line of symmetries. You've got to go through the middle. Axis of symmetry, line of symmetry, divides the parabola down the middle. What point has to be in the middle? on a parabola, what coordinate is in the exact middle? Say it again. Vertex. So shouldn't the line of symmetry have to pass through the vertex to be in the middle? So it's going to be a vertical line. X equals that same x coordinate from your vertex. X equals negative b over 2a. That same x coordinate from the vertex to put the line of symmetry in the middle. Okay. Let's try what's going to be on this board now. I want to get a little bit of practice on working with standard form quadratics. Identifying some of those key properties of a parabola. Find the following and sketch a graph of y equals x squared minus 4x minus 5. We've got an expression in standard form. It's not in intercept form. It's not in factored form. It's not in vertex form because I don't have any quantities. It's just all three terms listed out. The second power, the first power, the constant, the quadratic, the linear, and the constant term listed one after the next. Might be helpful for us to write down the a, b, and c values first. Nathan, what's the a value? What's the number, though? Don't give me the whole term. What number is out in front, even though there is no number there? 1. A, b, and c are just the coefficients, just the numbers. Don't say 1x squared. Just give me the numerical part, the 1. What's b? Negative 4. Give me the sign with the 2. B is negative 4. And C is negative 5. And give me those numbers, now we know what they are. Charlie, concave up or concave down? Concave up. Concave up. A is positive. That's easy. All right, let's do some x and y intercepts. X intercepts. If I look back at the notes on the other board behind Adam, it says we got to plug in 0 for y. Take that equation, solve it by factor. Y equals x squared minus 4x minus 5. Change y to 0. 0 equals x squared minus 4x minus 5. Yeah.
Oh, I was gonna answer.
You got to keep factoring now. Factor it.
You would do
X squared is what times what, Ben?
that would x squared is x.
X times x. So x's go here. We're just factoring like we had in our last unit. The other numbers come about by thinking what values multiply to make negative 5 and add up to be negative 4. What pair of numbers fits the bill? Multiplies to make negative 5 and adds up to be negative 4. Yeah.
Negative 5 and 1.
People always say that factored form or intercept form is the best to find the intercepts with. Well, now I've written it in factored form. So this should be pretty easy to find the intercepts on. Make this into 0. Well, we practiced a couple weeks ago on the first form. What value of x makes x minus 5 into 0, Paige? What's the first intercept have to be?
Positive
5 comma 0. What happens if I plug in 0? I'm sorry, what happens if I plug in 5 for x? What's 5 minus 5?
0.
0. Is 0 times anything else always going to be the whole thing into 0? What's the last x intercept?
Negative 1.
Negative 1. What number plus 1 makes 0? Negative 1. Our two x intercepts are 5 and negative 1 comma 0. I get there by setting the whole thing equal to 0 and solve by factor. All right, y-intercepts. Y-intercepts, plug in 0 for x.
Wait, I thought it was.
So when I do that, I'll have y equals 0 squared minus 4 times 0 minus 5. I replace each of those x's with zeros. X squared became 0 squared. 4 times x is 4 times 0. And what's 0 squared? 0 times 0.
0.
What's 4 times 0?
0.
So it looks like 0 minus 5 is all I have left. Just negative 5. Obviously, that's not too hard if you know what you're looking for. When you're in standard form, the y-intercept is just this last constant. Because the other two pieces go to 0. You can go ahead. All right. Pause here for a minute. Concavity, intercepts, issues so far. Okay, let's do the vertex. Vertex is going to be a little bit new for it because I need a new formula. The vertex, you get x and y. Start with the x coordinate. I need to do the opposite of b, negative b, divided by twice the a value, double the a value. So let's write this down. I need to know what negative b divided by 2a is. I have those a, b, and c values here. So let's start with opposite of b, negative b. B is negative 4, Dane. So what's the opposite of negative 4?
4.
4. Just switch the sign. If it's positive, make it negative. If it's negative like negative 4 is, you just made it positive 4, right? Okay. Opposite of b is 4. Now divide by 2 times a. Divide by twice the a value. Our a value is 1. So divide by 2 times 1. So yeah, 2 times 1 is 2. 4 divided by 2 would be 2. The vertex has an x coordinate of 2. I make the parabola as big or as small as possible using a x coordinate of 2. Now find that minimum value. What do I plug in to get the y coordinate? Which is, in this case has to be what? 2. Back on the wall it said, to find the y coordinate, plug x in. My x coordinate is 2, so find the y coordinate for when x is 2. 2 squared minus 4 times 2 minus 5. Evaluate for when x is 2. Austin, what's 2 squared?
4.
What's 4 times 2?
8.
Right, so I'm just doing our operations. Do powers first, multiplication next. I get 4 minus 8 minus 5. What's that become? 4 minus 8 minus 5.
Negative 9.
Negative 9. 4 minus 8, Kale said was negative 4. Minus 5 goes back to negative 9. Like. That's most of the new stuff when it comes to standard form. People struggle with finding the vertex. Got to know this formula first. Opposite of b over 2a. Switch the sign of the b value. It became 4. Double the a value. Twice 1 makes 2. 2 times 1 makes 2. 4 divided by 2 is 2. Once you know x, it's pretty easy to find y. What's the line of symmetry? It's x equals what number?
2.
X equals 2, right? The whole equation, x equals 2. Min or maximum, Sydney? Based on how this opens, is it going to be a minimum or maximum value? How is it opening? So is the vertex on top or bottom? If it's open and concave up, where's the vertex at? On top or bottom? That's if it's concave down. So it's a minimum, right? If it's concave up, the vertex has to be on bottom and open up from there. What is that minimum value? The lowest point I can reach on the parabola?
Negative 9.
Of negative 9, yeah. Any x coordinate you plug in has to always get out negative 9 or higher. Right? I can never plug a number in and get out like negative 10. That's not how a parabola is going to be working. All right, let's look at this last column here. Vertex, line of symmetry. Any issues finding something like that? Okay, make a quick sketch then. because I have a few points I can plot. I got a couple of x-intercepts at 5 and -1, 0. I can put those here. 2, 3, 4, 5. A y-intercept is 0, -5. And our vertex is 2, -9. If you want any more points, just pick other numbers to plug in for x. You can figure out where the graph's at for those x values. If you need any more points. I got a pretty good idea of where this is opening, based off of just using the intercepts and the vertex. Concave up from a vertex at 2, -9 with our x and y intercepts plotted.